All right, and welcome to 8-1.5 Mixed Review number 1. Now, in this very first problem, what we want to do is we want to go ahead and find the area of a regular heptagon below. Now, you'll notice that a heptagon has 7 sides, which is important because that means whenever we divide this thing up into 7 triangles, we'll actually have 7 central angles. Remember, going all the way around this regular heptagon is 360 degrees. So if we do 360 divided by 7, I think we get something like 128. But let me just go ahead and double check that for y'all. Pull up my handy dandy calculator. And so 360 divided by 7. Wait a second. 360 divided by 7. I stand corrected. Will give us 51.43 degrees. Okay, so why is that important? Well, remember, with a regular polygon, our goal is always to create this right triangle so that we can find the apothem. And what does the apothem do? It cuts things in half. So if I want to find this little red angle right there, I have to divide this number in 2. And I will get this is equal to 25.71 degrees. Well, that now allows me to draw my right triangle. So let's say we're searching for our apothem, and we can see that right up in here, this angle is at 25.71 degrees, and down below, the apothem cuts everything in half, so we know that this 8 divided by 2 will give us 4. And from here, let's go ahead and proceed. If you wanted to label this triangle, you could draw your arrow and say, you know what, there's our hypotenuse. We circle the angle. There's our adjacent. And of course, here is our opposite. Since we don't care about the hypotenuse, I can cross it out. And we can set up this formula. We can say, you know what, the tangent of theta is equal to the opposite over the adjacent. Well, in this case, we have the tangent of 25.71 degrees is equal to the opposite, which is 4 over our adjacent. Let's just call that x. Now, y'all should be fairly proficient at solving for x right here. So I'm going to leave y'all to do this on your own. When we're looking for the area of a regular heptagon, we know that our formula is the area is equal to 1/2 times the apothem, which is what y'all are finding when you solve for x, times the perimeter. And remember, you can get the perimeter by taking 8, the side length, and multiplying 8 times the number of sides. Alright, I hope this helps. Let's move on to problem number 2. Okay, problem number 2. Find the volume of the cylinder below after it has been dilated by a scale factor of 8. Alright, I'm going to show y'all, this is a fairly straightforward problem. I'm going to show y'all how I would do this personally. Let's first find the radius of this cylinder. We see the diameter is 7, so if we did 7 divided by 2, our radius should be 3.5. Okay, so we're also talking about dilating it by a scale factor of 8. So let's start there. We know that to find the new volume, we'll do the original volume times the scale factor raised to the number of dimension changes. So let's plug in some more things. How do you find the volume of a cylinder? Let's go ahead and do this in orange. It is pi r squared times the height. And here, let's say, well, what's our scale factor? Our scale factor is 8 raised to the power of 3. How do I know that? Well, anytime we're dilating volume, we're always changing 3 dimensions. Okay, so now I have my new volume is equal to pi times, remember our radius is 3.5 squared, times our height is 11.5 times 8 cubed. And if you can figure that out, you'll have the new volume. Alright? I'll leave y'all to figure it out on your own. Okay, problem 3. What three-dimensional figure would be generated by rotating a circle? Okay, so I want y'all to imagine here we have a circle. And I want to do this. I want to draw kind of an axis through it. Here's going to be my axis. And you can even hold out your hand in front of you. And I want you to start rotating your hand. And the way I'm rotating it, my thumb is coming towards me. And so what's happening? As my thumb is coming towards me, it looks like it's getting closer. Okay, and it's also not as wide. So as that rotates towards me, I see something kind of like this. And then as it rotates some more, I see something like that. And as it rotates more, I see something like that. And so on and so forth. And then as I continue to rotate it, and so now my thumb is facing directly at me, it looks very flat, and I continue to rotate it, and now my thumb is getting further away from me. Okay, so, like I'm picturing the edge of the circle like my thumb, and by drawing all these dots, it should be very apparent what three-dimensional shape have we created by rotating a circle. And I'll leave you to answer this one on your own. Okay, here we have problem number 4, and we have quadrilateral DEFG was rotated and dilated. Now we want to find the length of F double prime E double prime when given, and we're given several pieces of information. Now the first thing I want y'all to notice is if we are searching for E double prime, F double prime, we're going to have to also use EF, and we're not going to really care about GF. Like, that's some trap information. It's meant to be there to really trip y'all up. Now, where's the other trap information? See how we have this 4? We have to ask ourselves, does the 4 correspond with the 6, or does it correspond with the 5? And in this case, notice that we said that the shape was rotated. How can you reference a rotation? Well, aside from the letters, notice DG is the longest side, and so if we're going around this way, kind of going counterclockwise, the next thing we hit is DE. Well, here is the longest side over here. I put them in purple. And as we go counterclockwise, notice the next thing we hit is that D prime, or D double prime, E double prime. So we can say something like this. We know that on some level, we could think of this as ED is maybe congruent to E double prime, D double prime. However, notice it's also been dilated. So we have to multiply this by our scale factor. So how do we find our scale factor? Well, we simply do 5 divided by 4. So we could say this. 5 over 4 times the length of ED. Let's see, it looks like right here. Oh, I'm sorry. My apologies. One little switch here. Remember, we are searching for EF and E double prime, F double prime. So my apologize. We got our scale factor from ED. We got our scale factor from ED and E double prime, D double prime, but we're multiplying that scale factor by EF and E double prime, F double prime. Okay, sorry guys for the confusion. Okay, so what is EF? Well, EF is this 3x plus 9. I'm going to distribute. 3 times x is 3x, and 3 times 9 is 27. And now I can set that to my E double prime, F double prime, which is 8x plus 6. And I am so sorry for that word vomit there. Sorry for getting a little twisted. Alright, now I'm going to leave y'all to solve for x here. The only thing I would encourage you to do to make your life easier is I would change 5/4 into a decimal. 5 divided by 4 is 1.25 times 3x plus 27 is equal to 8x plus 6. Okay, and I'll leave y'all to solve for that on y'all's own. Let's go ahead and move on to our next example. Okay, problem number 5. Find the area of the triangle below. When given, guys, I'm going to stop y'all right there. Sometimes I think I always start with the first step, but I'm not totally clear on why. So what's our ultimate goal here? We want to find the area of a triangle, which we know is 1/2 times the base times the height. So our ultimate goal here, y'all, is to figure out what is the base and to figure out what is the height. Now, what else does it say? It says given EG is an altitude. Okay, so we're probably going to use the geometric mean, and ED is perpendicular to EF. Perfect. And we know that EG is 5, and EDG, this right here, will be 60 degrees. Okay. So how does that help us out? Well, the cool thing about 60 degrees is we know we actually have a special right triangle. So here's my special right triangle, and there's my 60, and I know that that's 5. Well, here, I'm sorry, let's do this a little bit different. For my special right triangle, I know I can follow this formula, where the short side is x, the third side is x squared roots of 3, and this hypotenuse is 2x. Well, if my x squared roots of 3 side is equal to the 5, what I can do is to solve for the short side, or this base dg, I can simply divide both sides by the square root of 3. Now remember though, 5 divided by the square root of 3 is not a very pretty number. We actually have to do something to it. We have to rationalize the denominator. And we do this by multiplying the top and bottom by the square root of 3. Which gives us our final answer, 5 square roots of 3 over, and the square root of 3 times the square root of 3 is just 3. Okay, so I now know that dg is 5 square roots of 3 over 3. Now why is that so key here? Well, it's key because since this is an altitude, I can label this base segment here A, this base segment here B, and this height C, and we know that we have this formula for the geometric mean. A times B is equal to C squared. And let's go ahead and plug in all the things that we know. We know, and let's call this bx. We can say, okay, well, A is going to be 5 square roots of 3 over 3 times our b term, which is x, which is equal to c squared, which is 5 squared. Now what is 5 squared? 5 squared is equal to 25. And what is 5 squared roots of 3 over 3 times x? Here is one of the few times that what I would encourage you to do is take 5 squared roots of 3 over 3 and get the decimal, because the math there without getting the decimal is going to be very confusing. So type this in your calculator, 5 times the square root of 3, and whatever that number is, divide it by 3, and then we'll write the decimal right there. And this gives us 2.89. Okay, now this is infinitely easier to solve, so we can divide both sides by 2.89, divide by 2.89, and we're going to get x is equal to, let's see, 25 divided by 2.89 is 8.65. And we now know that this length of GF is 8.65. And you know what, I would encourage you to take this 5 square roots of 3 over 3. Remember, we found that that was really 2.89, and now you have enough information to solve the rest of this. Let me kind of clean this up and just help you all out just a little bit more, because I know that this one's kind of a confusing problem. Okay, notice here we were searching for the area of the triangle, and so we know that the area is equal to 1/2 times the base times the height. Well, we know the height is 5, but what about this base? What you're going to have to do is add up dg, that 2.89, and gf, that 8.65, and then once you add those two things together, you can plug it in there and solve for the final area. Alright, let's move on to our last example. Just kidding, this was our last example. I'll see you guys in our next video.